Alrighty, this is still part of section 5.5, but now we're talking about scientific notation. Okay, because in scientific notation you do have to use some negative exponents, and so that's why this ties in with this section. Okay, just before we jump right into these examples, let me just make sure we clarify that when you multiply something by 10, like let's say you take the number 5 and you multiply it by 10, okay, it's going to make 50. Okay, and you'll notice that the number 5 is like 5.0. The decimal would be sitting right here after the 5. Okay, and when you multiply it by 10, sometimes we think of that as just moving the decimal over once, okay, and turning that into a 50. Now, when we move that over once, what we're really doing is multiplying it by 10. We're making it 10 times larger. We don't just magically move the decimal and poof, turning it into another number, but it's the multiplying by 10 that turns it into a 50. So if I were to take 5.0 and multiply it by 10 twice, okay, that would move the decimal over twice, once to a 50 and another time, and turn that into a 500. Okay, so I can rewrite that as 5.0 times 10 squared, because we know that 10 times 10 is the same thing as 10 squared. So I could say that 5.0 times 10 squared is equal to 500. Okay, so these are equivalent to each other. 5.10 times 10 to the second power, 5.0 times 10 to the second is equal to 500. Okay. Now, also what we have to consider here is this idea of negative exponents. Okay, and if you remember when we talked about negative exponents, if you have something like 10 to the negative 2 and you bump it to the bottom to make it 10 to the positive 2, this is like 1 over 10 squared, which is 1 over 100. It's 1/100th, okay? And so let's say that you wanted to take a number like that 5.0 and multiply it by 10 to the negative 2. Okay, 10 to the negative 2 does not mean you're multiplying it by 10 twice. It actually means you're multiplying it by 1/100th. So let's think about that. If I do 5 times 1/100th, okay, because that's what 10 to the negative 2 is equivalent to right here. Okay, so that actually means 5 times 1/100th, which is going to make 5 over 100 when we do top times top and bottom times bottom, which actually is going to make 1/20th, or in a decimal form, it's going to look like this right here. Okay, so you'll notice that 5.0 times 10 to the negative 2 is actually equal to this decimal. And just a kind of a shortcut way of thinking about that is it's like you picked up this decimal, and this time when you divided by 10 twice, you moved it back to the left twice, and you kicked that decimal in front of the 5 and then one more spot and filled that in with the 0. So it becomes 0.05 as your answer there. Okay, so that's basically what scientific notation is representing. It's representing the movement by multiplying by 10. And we use this for really small or really large numbers. It's very helpful. Okay, so a positive number that's in scientific notation is written as the product of a number, and that number A has to have these special qualifications. It has to be greater than or equal to 1, but it's got to be less than 10. Okay, and has an integer power r of r of 10, so it's going to be a times 10 to the r power. Okay, so it is going to be something multiplied by 10 to a power, and that a value has to be greater than or equal to 1 but less than 10. So basically what that means is there's only one digit that is before the decimal that's not a 0. For example, 1.5 is greater than 1 and it's less than 10. Okay, 2.6. 3.92, 9.14. These are all examples of numbers that can fit for those A values, but you cannot use things like 10.5 because this number 10 is not less than 10. You cannot use things like 0.82 because that is less than 1. And remember, we have to have numbers that are greater than or equal to 1 but less than 10. Okay, so these don't work. All right, so let's go over here and let's talk about scientific notation for a moment. So let's look at example A. You have 4,700. We want to write that in scientific notation. So we're trying to figure out how to write this as something multiplied by powers of 10. So if our A value has to be greater than 1 but less than 10, I need to place my decimal somewhere in here between the digits that would make it appear to be greater than 1 but less than 10. So if I were to place that decimal right in here between the 4 and the 7, this would be 4.7. Okay, now I could put 0, 0 on there if I want to. It's not really necessary, but I can think of that as 4.7 times 10 to some power. Okay, now my decimal is actually right here at the end, originally in the original number, and I've got it over here 3 spots away from where it should be. Okay, so that's my clue that it's 3 places away from where it should be. Okay, this is my clue that I'm multiplying by 10 to a third power. Now, if the number that I'm working with, my original number, is a larger number, okay, if you look at that number and it is a large amount, like here it's got the zeros falling at the end, okay, then you know you're going to be multiplying by 10 to a positive power. So this is going to be 10 to the third power. And that's kind of logical, because if I were to take 4.7 and multiply it by 10 3 times, I can see that it's going to bump my decimal 3 times and take me back to having that 4,700 for my answer. Okay, so here we go. This is in scientific notation. Now, if I have a really small number like this that's less than 1, okay, and I want to place my decimal, I've got to place it in here so that I have 1 digit in front of the decimal that's not a 0. Okay, right here, so it's a non-zero digit in front of the decimal. 5.81, I've got to multiply that by 10. Now, if I multiply it by 10 to a positive power, that's going to move my decimal to the right, and that's going to make it larger. It's going to turn it into a 58.1 if I multiply once by 10, or a 581. That's not what we need. Okay, what we need is actually a smaller number. Okay, so it is 1, 2, 3, 4 places away from where it should be. Okay, that decimal's 4 places away, and I'm going to be multiplied by 10 to the negative 4, because it's making a tiny number. And you should notice that where we place that number is, if you were to move it back 4 places to the left in the negative direction, it's going to turn back into the original number. So this is equivalent to 0.000581 using scientific notation. Okay, now you have to be able to go the other way as well, and you have to be able to take the scientific notation and put it into that standard notation. Okay, so this exponent is what we look for. It's 10 to the third power, which tells us we're going to multiply by 10 3 times. That's going to move our decimal to the right 3 times. It's going to make this number 5273.8, so that would be read as 5,273 8/10. And then we're done. Okay, now this next one, the exponent is a negative 5, which tells us we're going to move left, which is actually dividing by 10 5 times. So it's going to kick this decimal back over the 6, and then it's going to keep going back 4 more times. Okay, and for each one of those times that you move it back here, you're going to have to fill in with a 0 when you move it back 5 times to the left. So what you end up with is 4 zeros sitting in front of that 6, okay, because from right here where the decimal started to where it's being placed now, it's 5 spaces away. The 6 takes up one of those, the 4 takes the other remaining spaces. Okay, so in standard notation, here's our number, 0.000645, and remember, make sure you can see your decimal. Okay, when you move that decimal and you add those zeros to the front, you have to place your decimal where you can see it. Okay, so that's scientific notation.